Hello everyone, let's discuss the problem number 300. Once let's solve the problem number 300, longest increasing subsequence. So what the question states here, we are given an integer array nums. You can clearly see here, we are given an integer array nums. We have to return the length of the longest strictly increasing subsequence. Means strictly increasing subsequence is the word that you have to keep in your head, right? What we need to return, we have to return the length of the longest strictly increasing subsequence. We don't have to return the longest strictly increasing subsequence, rather we have to return the length of it, right? We have to return the length of the longest strictly increasing subsequence, nothing but LIS. The elements of the subsequence are not required to be contiguous, but must be in the increasing order. They might not be contiguous, they have said, means uh, they might not be present continually here, right? So they might not be present continually here, but one condition is they have to be in the increasing order. So they have to be in the increasing order. That's what longest increasing subsequence, right? So the question itself says here longest increasing subsequence means the this one, the elements of the subsequence, so the elements of the subsequence are not required to be in the contiguous, or it might not be present continually, but it must be in the increasing order. That's what they have given here, right? Let's come to the first example. Simple to understand. Let's come to the first example here. Just give me a second. Here you can clearly see we have the elements 1 2 3 4 5 6 7 8 elements we have here, right? So 10 9 2 5 3 7 101 and 18. So here in this case, when we consider 2, first we will consider 10 previous number is there, yes, previous number is not present, right? For the 9 also previous number is not present. So for 2 also previous number is not present. Like that we'll be considering, right? So in this case what we'll do, first we will consider 2, right? So first we will consider 2. So 2, that's fine. So next 5 is present. 5 we don't have to consider 5 in this case, because next element we have is 3, which is increasing. So they have said that the elements of the subsequence are not required to be contiguous here, right? So 2 3, we will ignore 5 here in this case, so we'll go with the 3. So next we have 7. So 7 is present after 3, right? So it is in the increasing order, so we'll be considering 7 next 101 we have. So 101 we will consider here. In this case, the longest, they have clearly mentioned in the explanation, the longest increase in subsequences 237 101. Sorry. So the length of it here is this one. Length we are considering, right? We should consider from 1. So basically the length is 4 here. So 4 we need to return as output. This is for the first example. Let's come to the second example here. So we are going with 0 1 0 3 2 3. So first what we will do, we'll consider 0 as first element. 1 next element, increasing order. 0 we will ignore, right? Again 3 we will ignore. So 2 we will consider here, and after 2 we can consider 3 here in this case, right? So this will be 0 1 2 and 3, right? So in this case as well, so we have to return 4. The length is 4, right? 0 1 2 3. So 1 2 3 4, the length is quite obviously 4 here. Let's come to this one, third example. We have all the same elements here. All elements are same here, right? So when all the elements are same, we have to consider only one element in this case. So there will be no increasing, there is no increasing element next to any element, right? All the elements are same. So here we'll be considering 1, nothing but 7 in this case. So we'll consider only one element, nothing but 7 in this case. For this particular example, we will return 1, right? So we have to return 1 in this case. I hope the question is completely clear. What we need to do is completely clear as well. Easy to understand, right? So let's discuss the approach first, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach first. So here, the first thing that we need to note down here is we will be going with the dynamic programming approach, or bottom-up DP, or the bottom-up dynamic programming, right? So I have considered the same first example that they have given in the question, so that it will be easier to understand. So these are the elements that are present in the array. So we have been asked to find the longest increasing subsequence, right? Length of the longest increasing subsequence. So here we'll consider 1 2 3 7 and 101. So they have said it might not be the numbers might not be present in the present continually, right? Or they might not be present, yeah, continually or contiguous, right? So that's what they have given in the question. So we will ignore this one, but they have to be strictly increasing, they have asked here. So 2 3 7 101 will consider, which is of the length, this one 2 3 7 101, which is of the length 4, right? Basically, so this 4 we need to return as output. We need to return length as the length of the longest increasing subsequence as the output, right? So here 4 is the length, so we'll be returning 4. So now we know this. We have already discussed this one when we discussed the first, second, and third example, right? Let's move on with the step-by-step execution here. So nums array, this one, the first example itself, the same. So you don't have to get confused here. So initial DP, what we'll do, we'll consider, will be, as we are going with the DP, we'll be initializing the DP array, and we will fill the slots with 1. Basically, we have here 1, this is 0 index, right? 0 1 2 3 4 5 6 7. So length is 8 here in this case. So length is 8. So 8 elements will be filling the DP array with 8 ones here initially, right? So let's start with the first one. So when I equals 1, j equals 0 iteration. So in this case, 9 less than 10. I equals 1, j equals 0 means I equals 1. This one index I'm speaking of. 9 less than 10, right here. J equals 0 means 0th index value we are considering 10. 9 less than 10, this one. So here in this case, this fails and DP stays, right? So let's move on with the when I equals 2 means 2, this 2 we are considering. So we will check for the j 0 comma 1, this one 10 and 9 we will check for. So we'll get the output to it is less than 1. So still this fails basically. Again DP stays, right? So let's move on with the next step. When I equals 3 means this one 5 we will be considering. 5 less than 2, yes, 5 is less than 2. Now DP of 3 will be DP of 2 plus 1, nothing but in this case we will get 2, right? We will get 2 in this case. Same goes with 4 5 6 7 as well. Means we are checking for this one. So just give me a second here. Okay, this is not working. Yeah. So here same goes with 4 when I 4 5 6 7 means here in this case 3 7 1 0 1 and 18, right? So we'll be doing same thing. 3 less than 2 element, this one 7 less than 3, 101 greater than 7, sorry, 3 greater than 2, right? So not less than 3 greater than 2, 7 greater than 3, 101 greater than 7, 18 greater than 7. In this case, what we'll do, DP of 4, DP of 5, DP of 6, DP of 7 will calculate. DP of 4 is DP of 2 plus 1, DP of 4 plus 1, DP of 5 plus 1, DP of 5 plus 1 again here. And this case it will be 2 3 4 4, right? I have just showed for the first 3. This will be same for the rest as well here in this case. So the final output that we got here is 4. Final output, I mean bottom up, we are going with the bottom up approach, right? The last cell basically consists of the number 4 here. The last cell consists of the number 4, or the final output that we got is 4. That itself we will return as output here in this case, right? So in this case, now that DP array consists of 111, 22, 344. This one, the value that we got here, this one, right? 2 2 3 4 4. So this one I'm speaking of. So here in this case, it will be 111, first 3, then 22, 22, then 344 we got, right? Same thing. The final output that we got in the last cell that we are returning here is 4, right? Same thing. We are returning the output 4. This one, right? Max length is 4. So the output that we got is 4, which is equivalent to the output that they have given for the first example in the question. So the approach works absolutely correct in this case. As we are completely familiar with the approach, we will be let's discuss the edge cases one by one very quickly, right? So the first edge case is for the only one element in this case. We have only one element in this case. So every single element is trivially an this one longest increasing subsequence of length 1. So output will be 1 in this case, right? So this is one the condition. only one element. Let's move on with the second edge case here. Strictly decreasing. We have 5, 4, 3, 2, 1 here within the nums array. So we this is for the strictly decreasing, right? So this is for the case strictly decreasing. Here no element increases at all. So LIS means longest increasing subsequence length is just any one number you can consider. So output will be quite obviously 1 in this case. So easy, right? So let's move on with the third edge case here. Strictly increasing. Strictly increasing means all the numbers are in increasing order. And in this case, we'll be considering all the numbers, length of all the numbers 1, 2, 3, 4, 5. 5 we have here in this case 1, 2, 3, 4, 5. This will be the length itself. In this case, 5 will be the output. Let's move on with the fourth edge case. All elements equal. So here output will be 1. So this is the same example that they have given in the example as well, right? I think example 2 in the question, the same thing, example 2 or 3. So I forgot, same thing. So all the numbers are same here. No next element is increasing here. So next element, so if we are considering this one as the current element, so the next element is not in the increasing order, right? So it should be 3, 4, anything greater than 2 basically. Same goes with 2. When we consider this as current element, so it is not increasing. So here it is not in the element is not in the increasing order. So same thing, when we consider this number, this is not in the increasing order. All the elements are same here. So any one we can consider here. In this case, the output will be 1. So here no strictly increasing subsequence. So longest increasing subsequence length is quite obviously 1. So these are the 4 edge cases that we need to keep in mind. First one is for the only one element. The second one is for strictly decreasing. The third one is for strictly increasing, and the fourth one is for all elements equals. These are the 4 edge cases that we need to keep in mind. And we are completely familiar with the edge cases as well as approach, right? We are completely familiar with the edge cases and approach. Let's we are good to write the code now. Let's start writing the code. So let's do one thing. We'll be making use of length of the nums array everywhere. So I'll just assign this one to the some variable. So I'll just consider here n equals. So I'll just assign this one to the variable n here. So nums dot length. This is fine. So the next step here is we have to initialize the DP array. We have to make use of the DP array, right? So we are going with the approach DP. So iterated value of the DP basically stores the longest increasing subsequence, that is ending at the index I. So I'll just go with DP here, variable DP. So new end of n means DP array of size n basically. So this is fine. So the next step is at least one element is always part of the longest increasing subsequence. So let's consider variable max length, or I'll just go with max length here. So let me initialize this one to the 1. Why we are initializing this one to 1? Because at least one element is always part of the longest increasing subsequence, right? So I have initialized this one to the 1. So the next one is we have to initialize all longest increasing subsequences lengths to the 1, right? So I'll just go with arrays dot fill. Means initially we filled suppose we had 8 elements in the first example. This one is consisting of the 8 elements. Initialization, what we did, we filled the DP array with 1 initially, right? So that's what we are doing here. DP comma 1. This is fine, simple, right? So the next step, so traversal, right? So we have to loop through each element from 1 to n minus 1, and also we have to check all the previous elements before I, right? So we are looping through the each element in the nums array, nothing but from 1 to n minus 1, right? So and also we have to check all the previous elements before I as well, right? So we have to check all the previous elements before I. Let's write simple for loops here, 2 for loops here. I'll just go with in from I to n minus 1. As I've said, I less than n, I plus plus. This is fine. The next step, also we have to check for all the previous elements before I, right? So I'll just go with j equals this one 0, j less than I here in this case. Let's increment the j. This is fine. Within the for loop, what we will do here, if increasing pair found means here in this case nums of I greater than nums of j, means if increasing pair is found, then we have to update the DP of I if a longer subsequence is found. Means I can write that one in this way. So if we have found the increasing pair, then we have to update the dp of I, right? If the longer subsequence is found. So how can we articulate the same thing in the form of code? Here I can just write iterated value of the dp equals, I'll just make use of the max here, math.max, basically math.max function, right? Math function, math.max of iterated value of the dp as well as this one, dp of j plus 1. This is fine, easy. So the next step after this one, we have to track the global max longest increasing subsequence. So I can just write this one in this way, maxlen equals math.max of maxlen comma dp of I. So this is fine. So the final step here is we have to return the maximum LIS found. Maximum LIS means longest increasing subsequence that is found. So in this case, we have considered the variable maxlen. So we have to return maxlen itself here. So I'll just go with return maxlen. So this is it for the code. So let me format the code once and let me hit the run button. I hope this works. Let's see. So we have some error here. Just give me a second here. So we have some error here. What error we have? Error not a statement. What happened here? Line number 9. So yeah, here bracket. So let me hit the run button again. Incompatible types. Int cannot be converted to end. The line number 4 where? So yeah, I have forgotten something, I think here. Oh, so this one has to be square brackets. I have forgotten here. So this is fine. So yeah, now you can clearly see here sample test cases are getting passed. So let me hit the submit button quickly. So I hope this works for all the test cases. Let's see. So yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct on this case, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is dynamic programming or bottom-up approach, right? It's bottom-up DP. So we can just call this one as DP. That's fine. So what is the overall time complexity here? Overall time complexity is big O of n to the power of 2 or big O of n square. Why it is big O of n square here? Because outer loop runs n times. This one, the line number 8 I'm speaking of. Outer loop runs n times and the inner loop runs up to n times. Line number 9 I'm speaking of, inner loop runs up to n times. We know this one, right? So we have already written the code. We know this one. Outer loop runs n times and the inner loop runs up to n times, right? So total is, in this case, it is n into n. So outer loop is running n times and inner loop is running up to n times. So overall time complexity would be quite obviously n into n, right? So which will lead to the n square, right? Or n to the power of 2. So overall time complexity here is big of n square, right? So what will be the space complexity here? The space complexity would be big O of n. So why it is big O of n here? Because we are making use of one array dp which is of size n. Here this one, line number 4 I am speaking of, we are making use of the dp array which is of size n, right? So here we are not making use of any extra space except dp, this one, dp array, and few variables we are making use of, right? So we are not making use of any extra space. In short, we are not making use of any extra space. So overall space complexity would be, in this case it would be big of n, right? So here we can optimize this one to the big of n log n by making use of sorting. You can just try that one. I just wanted to go with this solution. Basically it was easy to understand and we can just go step by step with this one, basically whatever the code that we have written, right? So we can understand this one easily step by step. That is the reason I considered this approach, right? You can just optimize this code to big of n log n as well. You can just try that one. I insist you to try this one. I insist you to optimize the code to n log n so that you'll understand this one better. Just try this one as well as just try to optimize this one to the n log n as well, right? I hope the complexities are clear. The time complexity and the space complexity for the code that we have written is big of n square and big of n. I hope the complexities are clear, and I hope whatever the code that we have written is completely clear as well. Right, for now, this is it. Thanks for watching, guys.